Now, if we take a look at example 6, it's going to be a vertical compression because you got the scale factor of 1/2. So what happens is I'm going to still start at 0, 0. When I go over 1, instead of going up 1, I'm going to be up 1/2. When I go over 2, instead of up 2, I'm going to take 1/2 of 2, which is 1. I'll get that point. If I go over 3, normally it'd be up 3, but I'm only going to be up 1.5. 1.5. And then I can draw my absolute value. So my domain is all real numbers. And my range is y is greater than or equal to 0. And then what happens is this is a vertical stretch. When compared to g of x equals the absolute value of x. Now let's take a look at the next one. This time it's inside. So when negative 1/3 x equals 0, well, that's when x equals 0. So I want to make my table. So x and y. So I'm going to put 0, go 1 and 2, -1 and -2. So if I take the absolute value of 0, or take it times negative 1/3, well, that is still 0, and the absolute value of 0 is 0. Let's do 1. If I take 1 times negative 1/3, I get negative 1/3. Take the absolute value of that, I still get 1/3. If I do 2, I take 2 times the absolute value, or times negative 2/3, take the absolute value, get 2/3. If I do negative 1, I get positive 1/3, the absolute value is 1/3. And then I get 2/3. That kind of looks familiar, doesn't it? So negative 2 and 2/3, negative 1 and 1/3, 0, 0, and I know it's symmetric. So this domain is all real numbers. My range is y is greater than or equal to 0. This is what we would call a horizontal stretch when it's inside. When you're doing a translation or when you're putting numbers inside the absolute value, it's going to be horizontal. And what happens is I'm taking my negative 1/3 and I'm flipping it. So I'm doing a horizontal stretch by a factor of 3. And we're flipping it over the y-axis, but you can't tell because we're doing absolute value. So anytime you're inside the absolute value and you're multiplying, you're going to do a horizontal stretch or compression. Here's how this is going to work. So if you have like y equals the absolute value of bx, your horizontal stretch or compression, let me rewrite that, that looks terrible. Still looks terrible. Is going to be by a factor of 1 over b. So if I take 1 over 1/3, I'm stretching this out horizontally by a factor of 3. Now, at this point, I'd like you to pause the video, see if you can do example 7 by yourself, then come back. Now, we have a absolute value of 1/2 x, which means it's going to be a horizontal stretch. because we're inside. The reason it's a stretch is because we take the reciprocal of 1/2. So I take 1 over 1/2, which is 2. Just flip it. So here's what happens. I take 0, 0. Normally, I'd go up 1. I take that back. I'd go over 1 and up 1. Well, since I'm doing it by a horizontal stretch of 2, I'm going to go over 2 and up 1. And then double that. If I go over 4, I'd go up 2. And then we can see there is your horizontal stretch. Kind of looks like a vertical compression too, doesn't it? But it's a horizontal stretch is what it is. Now, we got that one.